Welcome to Train Signal. I'm Chris Bryant, CCIE number 12933, and this is the OSI model video. And the layers that I've got here on the whiteboard, the ones we're going to talk about here, may be familiar to you. They may not be. But if you're going to get anywhere in networking, or especially anywhere with certification exams, because they really enjoy asking questions about the OSI model, then you need to know about these layers, and you will definitely know about them when we're done with this particular video. Now, the OSI model has value to us as network admins beyond passing a certification exam. It's one of those things that at one point you start learning them and you think, well, this is fun, but do I really need to know this stuff? And the answer is yes, because frankly, when I started studying networking, I thought the exact same thing. I would look at it and think, well, this is fine, but how am I going to use this? Now, definitely, you and I as network admins will be spending most of our time at the physical data link and network layers. But to truly understand everything that's going on in a network, you need to understand what's going on at all 7 layers. And before we get into the discussion of the OSI model, I want to tell you that the best way to break down anything that looks complex at first, and I don't care if it's a protocol or any kind of networking operation, is to break it down into smaller, more understandable parts. Because when you look at something as a whole, it can be intimidating. But when you break it down into smaller parts, you just learn it, one piece at a time, and all of a sudden you know the entire thing. Well, that's true of networking as a whole. And let's take a look at the OSI model here. This is the Open Systems Interconnection Reference Model, much more commonly referred to as the OSI model. And this model helps us to understand what's happening on a network by taking the entire process of sending data from one endpoint and getting it to another, because we've got to break that data down somehow, and we've got to have a structured approach and a structured process as to how we're going to do that. Because as you're going to see in a moment, when an end user interacts with the network, they do so at the application layer. And it's the physical layer that is actually going to take the data from one endpoint to another, and then the data's got to go back up the OSI model, as you'll see. But my point right now is that somehow we've got to have a structured approach to taking the data that you and I could sit here right here at the computer and enter, and we're entering it in a format that we understand as human beings, and it's got to be translated into ones and zeros, because that's the only thing the physical layer even understands. It's all ones and zeros, as you're going to see. So we're going to talk about how each layer of the OSI model helps that happen. And you really will find, too, as far as a practical usage for the OSI model, it's really going to help you in troubleshooting, because, again, it helps to give you a structured approach. But first, like I said, we're going to spend most of our time as network admins at the bottom 3 layers, but we need to know what's going on at all 7. And I will tell you, certification exams, Network Plus and others really enjoy asking questions about the OSI model, so we have to be prepared for that as well. Now, the first thing I want to tell you before we start addressing each particular layer is that networking personnel generally refer to layers by number rather than the full name. The physical layer being layer 1, data link being layer 2, and so forth, all the way up to application layer 7. When you hear about layer 2 addresses, we're talking about MAC addresses, as you'll see. Layer 3 addresses, we're talking about IP addresses. So what I've done throughout the video here is attempted to refer to them both ways, both by their name and by their number, to get you used to that. So having said all that, let's take a detailed look at the purpose of each layer and also where some common protocols and devices operate. And the application layer, hey, it's really simple. It's the one closest to the end user. Whenever an end user is interacting with the network, they're doing so at the application layer. And I've listed here 7 common protocols that run at layer 7. And if you have not heard of all the protocols or all the networking devices that I'm going to mention in this particular video, don't worry about it, because you're definitely going to know about them throughout once you've taken the entire course. And I expect you'll watch the videos more than once, and you can come back and perhaps some of this will gel a little bit better for you. But the common protocols that run at layer 7 that I would be aware of are HTTP, the Hypertext Transfer Protocol. That's our web protocol. FTP and TFTP, the File Transfer Protocol and Trivial File Transfer Protocol, both run at layer 7. Our email protocols run here, POP3, Post Office Protocol 3, and SMTP, Simple Mail Transfer Protocol, are both application layer protocols. The one I really want to point out to you here is Telnet, and if you've not used Telnet before, I'll give you a quick description of it. It's a way to remotely connect to and control a remote networking device. You can Telnet to a router, and you are actually going to connect to that router, and you can work on it like you were actually there. Now, with Telnetting, we're going to be using IP addresses, which work at layer 3. And we tend to use Telnet on a router from one router to another. And you can Telnet from one PC to another, but you Telnet from one router to another as well. And routers are layer 3 devices. So there's this misconception that Telnet is a layer 3 protocol, and it is not. It's a layer 7 protocol. So just keep in mind that even though we're using a layer 3 device and we're using layer 3 addresses, we are end users when we're using Telnet. In a blinding glimpse of the obvious here for you, the presentation layer is concerned with the proper presentation of data. But I bet you knew that without me telling you. So let me tell you a few things that you might not know about it. And that is that data compression and encoding are both performed here. Now, don't get data encoding confused with signal encoding. Signal encoding actually occurs at the physical layer of the OSI model, and that is where we're actually taking the data and turning it into that binary string of ones and zeros. So data encoding occurs at the presentation layer, signal encoding occurs at the physical layer. Character set translations occur at the presentation layer, and as I mentioned on the whiteboard, basically this layer takes data created in one application and translates it for use in another application. So almost anything that's got to do with how data is presented has something to do with the presentation layer. Now, we did not have specific protocols that run at the presentation layer, but there are file types. For those of you who've used Microsoft Visio, the TIFF file type, JPEG, MPEG, GIF, or GIF, however you want to pronounce it, they're all associated with this layer. And something else interesting, I had seen MPEG files, forever, and I really didn't know what it stood for until I came across it one day researching for this book. MPEG actually stands for Moving Picture Experts Group, and these are the standards for coding compressed video and music. So I don't know if you'll see that on your Network Plus, but just a little something extra there for you. The session layer, not much to say about it, but it's really the most important layer of the 7 in that it is the boss of the end-to-end connection. It's going to decide when the communication channels are built, how long they're kept up, and when they're actually torn down. And one session layer protocol you might want to be aware of is actually Novell NetWare's Service Advertisement Protocol, or SAP. And we're going to mention some other ones when we talk about Novell NetWare later. But again, the session layer, there's not much to say about it, but it really is the boss of the entire communication. Now, as for a layer that we have a lot that we could say about, that is the transport layer. We're going to talk quite a bit about this layer throughout the course. And this is where TCP and UDP both run here. And I mentioned that there are major differences between the two, and we are going to cover those in a separate video. They're very important for your Network Plus exam and an understanding of how networking works. Another protocol that runs here is Novell NetWare's SPX, which again we will revisit when we talk about Novell NetWare later in the course. But the protocols that run here at the transport layer are the protocols that actually handle delivery of data from one host to another. Very important detail here, this layer uses port numbers to differentiate multiple conversations between two hosts. Because let's say that we've got two hosts and one is sending a file via FTP and at the same time is also communicating with it as a web server. So you've got two different conversations going on there, but the transport layer will keep them straight by using different port numbers. One port number for FTP, and then another port number for web communications. So that's where our port numbers come into play. Now, the network layer, this is where routing actually occurs. And this is where you and I, as network administrators and engineers, spend much of our time. It's the network layer that actually handles routing. And routing is accomplished through examination of Internet Protocol, or IP addresses. And you've probably seen an IP address, even if you didn't know it at the time, something like 10.111, 172.10.1.1. And if you haven't seen them before, believe me, you'll have seen them by the end of this course. And when this IP address is added to a segment, it is known as a packet, because something I wanted to mention back here, bullet point 4 under the transport layer, data is placed into segments of this layer. When an end user or you and I sit down at a computer and we enter characters in, obviously those characters cannot be transmitted across the physical wire. Again, the only thing we can send across that physical line are ones and zeros. So we've got to start breaking that data down at some point into smaller and smaller units so that finally we do have ones and zeros to transmit across the physical wire. In the top 3 layers of the OSI model, we'll mention those again. There's session, and here's presentation, and here's application. At the application, presentation, and session layers, the data has not yet started to be broken down into different units. But at the transport layer, it is, as you'll notice, it's placed into segments. And then at the routing layer, I should say the network layer, it is placed into packets. Those are the kinds of details you really want to watch for certification exams, because they're really going to enjoy asking you that kind of thing. And I've listed several different layer 3 protocols there. The main one we work with is IP, the Internet Protocol, but ICMP, IGMP, ARP, and reverse ARP are all protocols that we'll cover in this course if you have not seen them before. As we continue to head down to the bottom of the OSI model, we arrive at the data link layer. Now, the data link layer places data into frames. The units are actually getting smaller and smaller. And it is the data link that is concerned with sending data across a particular link. Now, as I'll mention several times throughout this course, we use MAC addresses at this layer, but MAC addresses are also known as physical addresses, layer 2 addresses, and burned-in addresses. And I want to stress here and again several times through the course that physical addresses have nothing to do with the physical layer of the OSI model. They are data link layer addresses. They're named that because they physically exist on a network card. Just a couple of devices here that operate at this layer: switches, bridges, and wireless access points, commonly referred to as WAPs, operate at this layer. And yeah, it's hard to say that without laughing, I admit. The data link layer also performs some error detection, which is otherwise known as error checking, but that is not error recovery. And before we go any further, I want to point out there's a big difference between error detection and error recovery. Error detection is simply finding the error, but error recovery is actually fixing it. You may think, well, that's another blinding glimpse of the obvious. I already knew that. But sometimes these terms get used interchangeably, and they are not interchangeable. And again, the data link layer has a mechanism for some limited error detection, but it does not perform error recovery. And the data link layer finds errors through use of the FCS, the frame check sequence, and an operation also known as the cyclic redundancy check, or CRC. And if this sounds complicated, hang in there with me, because it is not complicated at all. Here's an outline of the FCS and the CRC processes, and also some other notes here about the link layer, the data link layer. And what happens with these FCS and the CRC and how they work is that the sending host is preparing to send a frame, and what will happen is that host will run a mathematical operation called an algorithm against the contents of the frame. And the host will then place the result of that algorithm into the FCS field and then send the frame. The destination host then receives the frame, and then that host will run the same algorithm against the contents of the frame and compare it to the contents of the FCS. So basically, both the sender and receiver are going to run the same mathematical formula against the contents of the frame, and the destination already knows what the source's answer was by looking in the FCS. And then, if the destination host agrees with what it sees in the FCS, then the frame is assumed to be intact and it is accepted. But if the algorithm run by the destination host comes up with a different value than that contained in the FCS that it received, the frame is considered corrupt, because what happened is something happened to it during transmission. And since it is the destination host that discovers this corruption, it is error detection, but it's not error recovery. Also looking at two sublayers of the data link layer, this is the only layer that actually has two parts, and it's represented in most drawings by just one. Here you see the OSI model, but notice that the data link layer is here broken up into two separate parts. And you will rarely see OSI model documentation today that really goes into detail on these two. I want you to know it for the Network Plus exam. It doesn't hurt a bit. And it's actually pretty simple. It's split into two separate parts, as you see. The logical link control, the LLC, and the media access control, the MAC layers. It's a good idea to know that the LLC layer is interacting with the network layer while the MAC layer is interacting with the physical layer. Again, with these two, the LLC sublayer has several optional features, including error recovery, flow control, and acknowledgments, or ACKs. And how you configure those is far beyond the scope of Network Plus, but it's a good idea to know that the LLC sublayer is defined by IEEE 802.2. We're going to be revisiting that a couple times throughout the course as well, and what these standards are. The MAC layer, that's actually the layer that applies the MAC destination address to the frame, and it also decides where one frame ends and the next one begins. So those are both good things to know about the LLC and MAC layers. Again, that the LLC layer is defined by IEEE 802.2, and the MAC layer of the data link layer, the one right next to the physical layer, actually decides where one frame ends and another begins, and actually applies the destination address to that frame. The physical layer, so we've gone through all that stuff, going all the way down from the application layer down to the physical layer. And, you know, I always like to tell my students, and something else that I say when I fix something, people are thanking me, I just always say, hey, you know, it's all just ones and zeros. You just got to get them going in the right place. And, you know, that really is true, because everything we do is as fancy as we get today with today's networks, with voice over IP, streaming audio, streaming video, and it's just going to get bigger and bigger and bigger. It's all just ones and zeros. And that's what the physical layer is all about. Because the physical layer, the only thing the physical layer understands are electrical signals. And those electrical signals are either on or off, right? I mean, you don't have a medium setting on a light bulb, say. It's either on or it's off. It can't be somewhere in the middle there. There's no gray area. So what we've got then is either an on signal representing the number 1 or an off signal representing the number 0. And that's what it is. You know, you've probably seen ads for computer schools, and or seen it on the cover of some computer books where they have streams of ones and zeros to make it look like a real technical document. Well, that's all it is. It's just ones and zeros at the physical layer. And all of your physical and electrical specifications for any electrical and physical devices, those are defined at layer 1. And we do have some hardware devices that fall into the layer 1 of the OSI model: hubs, repeaters, and network interface cards. And we're going to be talking about those throughout the course as well. But those are all layer 1 devices. And as I mentioned earlier, signal encoding occurs here at the physical layer, and that is the actual process of taking the data and translating it to a series of electrical signals. Now, almost every layer of the OSI model is going to add a header to the already existing data. And additionally, as I mentioned, at the transport layer, the data will begin to be placed into smaller and smaller units until it's ready to be sent across the physical wire. And here's how data is referred to at each layer of the OSI model. At the application, presentation, and session layers, the data is still referred to as data. We're more worried about getting the communication set up with the remote host. The presentation layer, of course, is preoccupied with how the data is going to be presented so it can be understood. And the application layer is simply the layer where the end user is interacting with the network. But the data has not yet begun to be chopped up, if you will, or placed into smaller units for transmission, eventual transmission across the wire. At the transport layer, we are dealing with segments. At the network layer, data is placed into packets. At the data link layer, it's placed into frames. And at the physical layer, as I always say, it's all ones and zeros. Here's an illustration of how the OSI model represents communication between two different hosts. And we've got a sender and a receiver here. And the OSI model is actually put into action twice during any communication. Now, the sender's data is going to flow down through the OSI model, and when the data reaches the recipient, it's going to flow back up the OSI model. And headers are placed onto the data as it flows down the model from the sender, and they're removed by the matching layer on the other side of the communication as the data flows back up the model. For example, the header placed on the data by the application layer on the sender side will be removed by the application layer on the receiver side. So we're putting headers on as we go down the model, the data goes across the wire, and then as it comes back up through the OSI model, the headers are actually removed. I want to mention to you here, I'm going to mention this during the OSI lecture, and we're going to mention this again when we actually talk about packet filtering. Now, packet filtering is one of those, the name is the recipe features, but you've got to know what value is being used to filter these packets. And in case you don't know what packet filtering is, that's fine. Let me explain it to you. And actually, we'll bring the previous drawing back up. Now, let's just say for whatever reason that we don't want a certain kind of packet to be able to be sent from the sender to the receiver. Let's just say that we don't want one of them using Telnet to communicate with the other. That's packet filtering. What we can do is actually block an IP protocol and a port number to prevent Telnet communication between the two while still allowing other communications to go through. We could allow data communication, we could allow FTP, we could allow email to go between the two of them, because we will often have situations in networking where we do not want one kind of communication to be allowed, but we do want to allow others. This used to happen at schools a lot back before a lot of web-based applications came out. A common refrain by the principal of the high school would be, I don't want the students to be able to use the web while they're at school. But we still had to allow other kinds of communications through their network. So what you did was you just blocked port 80, which is HTTP port, and you were fine. Well, that's packet filtering, and I see some discussion out there about where it occurs in the OSI model. You know, is it layer 3 with the IP addresses? Is it layer 4 with the port numbers? It's really actually both, because at layer 3 of the OSI model, that's where IP addressing comes in. So we are performing some kind of packet filtering there because we're going to use that as a criteria. But at the same time, it's also going to be taking place at layer 4, the transport layer, because that's where ports and port numbers come into play. And it's very common to have packet filtering involve both layer 3 and layer 4. So in case that comes up in a discussion, you now know a good way to put it, that since packet filtering filters on both IP addresses and can use port numbers, it occurs at both layers 3 and 4 of the OSI model. We're going to take just a moment here to review the 7 layers of the OSI model, but before that, I want to give you a bit of an exam tip here, especially if you've taken other certification exams before. I know the OSI model is not the most exciting material in the world. And it's certainly not going to be the thickest video that you have here as far as the depth of the material. But again, don't underestimate this material. Know it cold. Know the protocols that run at the different layers. Know how data is referred to at the different layers, because frankly, these should be free points for you on any exam. The OSI model is not particularly difficult. It's probably going to be the easiest thing you see in this entire course. But again, I would just remind you, it's very important material to know. Vendors enjoy asking about this. CompTIA is probably going to enjoy asking about it. And at the same time, it really does help you gain an understanding of what's going on at the network. And it really helps with troubleshooting down the road. You will be amazed at how often you refer to the OSI model. So again, just a quick review here, maybe an addition or two, just to give you some additional information. Here at the application layer, you see the protocols that we know run here. And another thing to keep in mind here is that the print and file services run here as well. So print and file services run at the application layer. We talked about the protocols, particularly HTTP, FTP, and Telnet. You really want to keep Telnet in because there's a misconception that that runs at layer 3 of the OSI model, and it does not. But again, when the end users are interacting with the network, they're doing so at the application layer. Let's move that up. The presentation layer, again, just like it says, this layer is concerned with the proper presentation of data. We've got data compression here. We've got data encoding here. We've got character set translations here. Almost anything that has anything to do with how data is going to be presented. And again, we do not have specific protocols that run here for those file types. MPEG, JPEG, TIFF, GIF or GIF, however you want to go. Those are the presentation layer file types you want to know about. The session layer, as we mentioned, not a whole lot to mention here, but it's a very important layer because this layer is really the boss or the manager of the entire host-to-host communication. Because as we mentioned in the drawing between the two systems communicating, the communication channel itself is built, maintained, and torn down by the session layer. So very important stuff there. The transport layer, this is where data begins to be divided. It's divided into segments. TCP operates here, UDP operates here, Novell Networks SPX operates here, and again we will talk about the TCP and UDP differences in a later video. As far as the network layer, this is where routing occurs. This is where IP addresses come into play. Layer 3 switches also run here, and I want to mention that here there is such a thing as a layer 3 switch. Now, if the exam asks you about a switch, they're talking about just a basic layer 2 switch. But I want you to know for the real world that there are layer 3 switches out there. They're becoming more and more popular. Basically, they're switches that have router capabilities. And you can make some ports switching ports and some ports routing ports. And we'll go into depth in another video into that too. But I do want you to know they exist. I don't want to just tell you, hey, there's no such device as one that goes between layer 2 and layer 3, because in today's network there is. It's a layer 3 switch. As far as the data link layer, this is where switching actually occurs. Switches handle frames, which is the data format of the data link layer. MAC addresses are used here, and switches, bridges, and wireless access points, or WAPs, are the devices that run at that layer. Talked about the frames check sequence and the cyclic redundancy check. And we come back to the physical layer. It's about what you'd expect. Anything to do with the physical components. That includes cable and connector specs. Two other devices that you might want to know about for layer 1. Transceiver and a token ring MAL, or multi-station access unit. We will talk about MALs when we talk about different network topologies, but basically, as you'll see throughout the course, we'll talk about transceiver and token ring MAL in good time when we talk about the actual devices you're going to find on a network. But it's a good idea to keep in mind that those are also layer 1 devices as well. So whether this was the first time you've been exposed to the OSI model, or whether it was a review, I thank you for your time. Again, don't underestimate, I should say, the importance of knowing the OSI model, where different devices run, where different protocols run, and the basic purposes of each layer. And that about wraps it up for the OSI model. So I thank you for your time, and I'll see you on the next video.